Oh, hi Nat, can you hear me?
Yep. Hey, AV.
Yeah, okay. Okay, I think we can start now. Let me introduce a bit and then your turn. Okay. Hello everyone. Welcome to your weekly technical sharing session by Super Team Vietnam. I'm Vĩ, and today I'm very happy to welcome Nat, the developer relation at Zero, who will be sharing with us about Zero. Okay, Nat, could you please introduce yourself before starting your session?
Sure thing. Hey, everyone. So my name is Nazrin, and let me move to the next slide. Yeah, I'm a developer relations engineer here at LayerZero Labs, focusing on Solana integrations. What that means is that projects that want to integrate LayerZero and have their integrations be on Solana, I'll be the one to helping. I'll be the one to help these projects. You can find me on OX Nazrin on Twitter. Cool. So should I begin, V?
Yes, you can be. Yeah.
Awesome. Yeah. So welcome everyone to this talk on Intro to LayerZero. LayerZero is an omni-chain interoperability protocol. What does that mean? So for app developers, which I'm guessing some of you tuning into this are, it allows you to permissionlessly interact with any chain that we support. Currently, it's more than 120 chains, and we've been live on Solana since mid 2024. So this presentation is going to be about LayerZero, but along the way, you'll also learn about cross-chain messaging. So hopefully you'll pick up some useful things, even generally about cross-chain messaging. So it's going to be a technical talk, a technical overview, which assumes that you have a basic understanding of blockchains. And then at points in the presentation, I'll open up space for questions, but along the way, feel free to type them into the chat on whichever platform that you may be tuning into. Cool. So I've already introduced myself. And the best way to begin is to talk about physical bridges. So just in the real world, bridges are built to connect separate masses of land, right? And the reason that we do this is to connect people together to allow for a exchange of information or physical information or digital information more freely, and also for the transfer of assets and goods and services. This is the same thing that we want to do in the world of blockchains because we now live in a cross-chain reality. So I know that the people tuning into this stream might be leaning more towards Solana, but there are also other blockchains with their own characteristics. And we know that there are significant trade-offs depending on the chain that we choose in terms of speed, cost for finalizing transactions, and also security. And at the same time, each chain, just like each country or each geographical area, would have its own set of users, assets, and also opportunities. And as developers, you might want to leverage the unique strengths of each chain. And the trend is that over time, developers are working with more and more chains, right? This is the Electric Capital Developer Report from 2023 that shows that 30% of developers are deploying on more than one chain. And I'm very sure that the updated metric is going to include a higher percentage of developers who are working with more than one chain now. And when we think about this, blockchains that are isolated by nature, it's a bit like islands that are separate from each other, right? But they need to be able to communicate to each other. So when we think about this, what we really want to have is a global ledger that makes it simple and seamless to communicate and move assets between each other. And if we want to build such a system, at LayerZero, there are a couple of principles that we believe in that are necessary to build the system. Firstly, we have to make it permissionless to allow for anyone to build on top without being censored. And when I say censored here, it's not only about being able to access the protocol, but also about having a guarantee that any message that you send across chains can always be delivered. No entity should be able to censor you without you having a way to circumvent the censorship. And the third principle is immutability. The interface and core contracts of a protocol that's used for this cross-chain communication should be consistent throughout, right? Uh, because it's going to be used for sending and receiving messages, and there needs to be a guarantee that it will not change. Otherwise, at any point in time, the behavior of the protocol might change, and that is a security risk. So before we talk about cross-chain transfers, let's just touch on how token transfers work on a single chain. It's pretty straightforward, right? So on Solana, for example, a token transfer, a token would go from a source account to a destination account. Very simple. Everything can be done in one instruction, one transaction. Now, things get a bit more complicated when we need to send tokens across chains. And why is that? Well, there's not a single standard for communicating with across chains, across different ecosystems. The blockchains might not know about each other, and effectively, there is a walled garden for each chain from different ecosystems. So, to have a sufficient cross-chain transfer solution, we need a way to transfer assets from the source chain uh, and having the certainty that the asset has been deducted from the source chain and then be able to credit the same amount or after the amount after fees in the destination chain. So how has this been like historically? So in the past, traditionally, there would be some monolithic provider, which means that there is a monolithic security model securing the cross-chain transfers. A centralized entity would sit in middle and listen to the source chain, and upon a cross-chain transfer transaction event, they would then take that information and then deliver the assets to the destination chain. Or it might be a collection of signers, a group of providers that are either off chain or on chain that's verifying each message, or even a whole blockchain, a middle chain in between the source chain and destination chain that guarantees the message delivery. The problem with this is that when the monolithic security fails, um, then it can be quite bad, because when you go with a provider who's verifying messages for you, you're essentially joining a bunch of other application developers and users and saying that you believe in the same trust assumptions as them and that those trust assumptions won't fail for you. But when those trust assumptions do fail and that monolithic security fails, then all applications are at risk, not just your application, but every application that is relying on that monolithic security bridge. So it's not just assets that are at risk, but also data integrity and even identity. So this one size fits all model doesn't make sense for cross chain messaging. So this chart, needs a little updating because we've since had the Bybit hack. So the figure is now at 3 out of the 5 largest crypto hacks historically are bridge related, and 3 out of 5, that's still a majority. So security, it's a major issue when it comes to cross chain messaging, and monolithic security is too big of a risk. So the problem with the monolithic security model is that it just presents itself as a too attractive of a target for malicious actors. Because again, the total value at risk is all the applications that are um, deployed to use the monolithic security bridge. So all the assets that those applications rely on the bridge for, they're at risk. So it's a single pot, right? It's a single honeypot, and that is very attractive to attackers, and that incentivizes attackers to exploit this monolithic security bridge. So everything can be targeted by exploiting a single security model or a single group of closely related providers. Now, this relates to how there is a trade off always between security and cost. And monolithic security solutions force application developers to choose a specific ratio or balance between security and cost. So either you have to go with a bridge provider that has a very low cost, but you also have very low security, or you go for one that has a very high security, but the trade-off there is that there's also a very high cost. Now, and if an application ever decides to switch from one monolithic solution to another, then the cost is very high because this requires contract changes, new audits to be done, and also new deployments to be made. And so in total, the costs are just too high. And even if there is a better security solution out there, some apps just cannot afford to make that switch. So how can we do better, right? So the better way to do this is that we let applications choose the right balance between cost and security, because not every application has the same cost and security needs. We need to be able to allow for applications to move along this line as freely as possible without needing to change interfaces or redeploy contracts. They should be allowed to choose any point that they want to be on this diagram. So going back to this slide, we know that we are in a cross-chain reality. We know we make trade-offs based on speed, cost, and security when it comes to blockchains, and different apps need different levels of security and cost effectiveness. So why should our cross-chain solution be any different? What we want, right, when it comes to this global ledger that connects different chains together, is to be able to configure the pathways that connect the different chains in a way that is permissionless, censorship resistant, and also immutable, but still allow for apps to decide for themselves the right balance between cost and security that they require. And this is how LayerZero provides that. LayerZero provides a messaging layer that ensures that information can be verified as having come from a certain blockchain and be able to select the messaging layer's verification parameters, such as number of block confirmations to wait, the required verifiers, each with their own security methods, the optional verifiers, and the threshold for the number of optional verifiers for a message to be considered verified. LayerZero provides a function call layer that is responsible for calling contracts across chains. So it's not only information or tokens that you can transfer, but you can also trigger for contract calls in the destination chain. And also an omni-chain application layer that makes use of the raw bytes sent across chains at that omni-chain messaging layer. And these raw bytes can be adapted for any use case that you want. How does message sending work? The messages that are sent can be, again, just raw data, or it can be for token transfers, or it can be for triggering contract calls on the destination chain. An omni-chain application is called that would call the send method on the endpoint on the source chain. The endpoint would make use of the application's selected message library, which I'll touch upon in a later slide, and make use of the configuration set by the application that states the parameters such as the number of confirmations to wait on the source chain and which verifiers and executor to use. The application determines the message verification and execution logic. The verifiers that the application has configured would sign off on the message before the message could be sent to the destination chain before it can be executed. So each verifier could have their own security approach. Each verifier would also commit their verification in the destination chain. And after the message has received enough verifications, it can then be executed on the destination chain. So this execution can be made either automatic by assigning an executor, abstracting away the destination chain gas by paying for it on the source chain, or you can allow for anyone to manually trigger execution on the destination chain so that it's permissionless, removing the reliance on any one executor. Okay, so I'm gonna pause for a bit here because I know it could be a lot. We're now at the midpoint of the presentation. Does anybody have questions? Okay, so I'll continue to the next slide. So I've mentioned the LayerZero endpoint. What is the endpoint? The endpoint is the entry point for sending and receiving messages. So on the source chain, when an application wants to send a message, it will first interact with the endpoint. And then on the destination chain, once the message has been verified, then the endpoint is also responsible uh, for assisting in for being the interface for executing the payload on the destination chain. So the endpoint by itself is not responsible for interpreting or verification of the raw bytes sent. That is the job of the message libraries when it comes to verifications. And it's also immutable, like the endpoint. So message libraries are append only, meaning the ones that have been deployed on chain will never change. The only way that applications will use new message libraries that are published is by opting into them. Only application developers would have this power to switch over to a new message library that has been published. This design guarantees that applications will never be forced to accept new top-down protocol code while still being able to update existing OApps to new configuration setups. As an example, LayerZero is currently on version 2 of the protocol. Applications that were on version 1 were not forced to use the new message library, but they are free to switch over whenever they want to. So I've mentioned verification and verifiers. In the LayerZero protocol, verification is done by DVNs, decentralized verifier networks. What can be a DVN? So a DVN can be set up by anyone and use any verification technique. These are some of the DVNs with their own verification techniques. um, and you're able to choose any of them based on what you need, whether it's a ZK-like client by Polyhedra, a cryptographically secure state-proof method by Lagrange protocol, or you can even use Google Cloud and established Web2 entity into your security stack. You can even choose to set up your own DVN um, by setting it up and adding it to your security stack. The configurable nature of the security stack allows you to future-proof your application because new techniques might come out that are more secure and more efficient. And you can easily add these new verifiers using these new techniques into your existing deployed application's security stack in a way that doesn't violate any of the three principles that we talked about earlier. Going back to this slide, the beauty of the security stack model is that it allows for applications to make use of new validation techniques. If there's a new validation technique, as I mentioned, then app developers can update their security stack to make use of the DVNs that make use of that new security technique. And all of this is done without any change of interfaces. Now, LayerZero provides for vertical composability, allowing you to configure parameters for execution and at endpoint level, and also allow you to configure things at the OAP level. But other than vertical composability, we also give you horizontal composability. So not only are you able to trigger function calls on the destination chain, you can also chain function calls on the destination chain in a way that is composable, such that subsequent actions failing doesn't result in the whole set of actions on the destination chain failing. So, say for example, you have a token transfer and you have a compose action for it to be swapped into another token. If that swap fails, for example, maybe for slippage reasons, then you still have a successful cross-chain token transfer because the later action failing doesn't cause the whole set of actions to revert. And you can also even use the gas drop feature that allows you to pay with a source chain gas and receive the gas token on the destination chain. And this could be used to fund new wallets or new contracts. To recap, zooming out, looking at our abstraction for cross chain messaging and cross-chain token transfers. To send and receive messages, you can use a common interface via our LayerZero endpoint contract or program. And to validate messages, you can use our configured you can use your configured security stack that is not at risk of total failure due to any single verification technique. So what this means is that if you're on multiple chains and using multiple DVNs, in the case where one of your verifiers fail, you still have other verifiers and other verification techniques that are securing your application, and you still be able to transfer messages and guarantee finality at the destination. The worst case scenario is that your messages are stopped temporarily while you swap out your verifiers before the paused messages are resumed. So with LayerZero, you can build omni-chain applications for whichever use case you want, as you are in control of the decoding and encoding of the raw bytes that are sent across chains. You will have application layer security, as you can configure your omni-chain applications to allow for only known addresses on the other chains. We call this peers on remote chains, on peer chains. You'll have access to custom configurations, as LayerZero provides OAP developers with a high degree of configurability. As mentioned before, you can choose the number of block confirmations to wait, and the reason that this is important is to protect from block reorgs. You can configure the security stack for the exact number of DVNs and for the verification techniques that you want. You can make use of either the executor run by LayerZero that allows for complete abstraction of destination gas by paying for it on the source chain, which allows for automatic execution, or uh, allow for or opt for manual execution, which makes it permissionless. And this method is always possible. So no application is made hostage by the liveness of the executor run by LayerZero. You can configure the gas for execution. So for example, for token transfers that utilize burn and mint, you can specify exactly how much gas you want to provide for the mint transaction on the destination chain, and also the message value, and also the gas for the compose call, which refer to which refers to the chain function calls. And you can configure whether and how much gas to airdrop on the destination chain. You can also decide on the ordering of messages. For token transfers, for example, you might not care about the order of messages, but for other use cases, for governance, for example, you might want to enforce strict ordering such that if nonce once was delivered but nonce two was not, then nonces three and four cannot be delivered and can only be delivered after nonce two has been retried and delivered. You can configure max message sizes to prevent issues such as overflows when too many inputs are provided. You can make use of composability, both vertical and horizontal, which means you can chain function calls to happen after LZ receive is called. And all of this builds up to the omni-chain tech stack. Your application, no matter the use case, can use the LayerZero protocol using either our contract standards or your own smart contract interface, and communicate with the LayerZero endpoint on any chain that we support. And all of this provides not only a consistent interface that never changes, but also configurability and ownership over your application in case things do need to be updated because better techniques or systems are developed. Okay, so those are the majority of my slides. Any questions?
I just have a question about the difference between zero with wormhole.
Okay, yeah, so I try to focus on LayerZero itself, but
Yeah,
Wormhole, for example, uses a fixed set of validators that they call guardians, right?
yeah, yeah.
And the way that LayerZero differs is that let me go back to the slide. We use DVNs, decentralized verifier networks. So here, you can choose any DVN that is live. I think right now we have 45 or more DVNs already, each with their own security techniques. And also, you can set up your own DVN. So, say for example, you're hyper cautious about collusion of other DVNs. You can set up your own DVN, and you can have the, the guarantee that your own DVN will not collude against you. But at the same time, you want a higher degree of certainty around correctness. So you add another DVN. So your security stack requires two DVNs, one that you run yourself, and another one. And this is the beauty of the LayerZero model, because it gives application developers the ability to configure their own security stack, which is not the case for other approaches that utilize fixed validator sets.
Yeah. Okay,
Cool.
so if I'm building application on Solana and I want to integrate with Zero, do you have any SDK or resource for the developer who want to integrate?
For sure, yeah, it's on our um, docs page. But before that, let me give a shout out to our breakout hackathon track. So LayerZero is hosting a breakout hackathon track, and to everyone watching this video, if you submit, you have a very high chance of winning, as highlighted by that box, because there's not been a lot of submissions. So this is the alpha for everyone, and it's a pretty sizable track. I believe we might be the second largest track right now for the breakout hackathon. So please do that. But in terms of SDKs, so here this QR code, if you scan this QR code, oh, it's currently blocked by the super team logo.
Uh,
Is it possible to be moved, V?
let me.
Oh, okay, then it's a StreamYard logo. um okay, let me see, let me move this, let me exit full screen, and let me just yeah, okay, so everyone should be able to scan that QR, and that will lead you to our documentation page, which mentions the SDKs that are available. Cool. Any other questions?
I think Hiếu have a question about the consensus. Can you see it?
I don't see it in this in StreamYard. Like, where can I see this question?
On the right side of your stream, yeah, it have a common
Oh my
section.
God, I've been viewing the wrong tab this whole time, guys. I am so sorry. Like, I've been on private chat. I'm such a noob at this. I apologize. Now I see everybody's GMs and I'm so
Yeah,
sorry.
yeah, yeah. Yeah.
Okay, thank you for commenting, guys. I'm only seeing it now. Everyone. Okay, so again, the consensus, right? So to simplify things, uh, consensus. Why do we care about consensus, right? It's about the validity of messages, yeah, and validity of messages in our terminology, it's the verification of messages. And so this relates back to the same question, and I love these questions because this is around security, and especially in the crypto space, it's more important than even in Web 2, right? So these are great questions. Yeah, let me go here. So again, in your security stack configuration, you're able to say, hey, I want two DVNs to be always verifying my messages, and then I want one more DVN, but then I don't care which DVN it is. So maybe it could be either Nethermine or Google Cloud. Okay, either one of them I need. So in total, I need three DVNs to verify my messages before they're allowed to execute on the destination chain. So these verifications are what's required before a message can be executed. And again, for each verifier that you choose, it has its own security model or trust assumptions. You can choose, for example, Axelar, which is a cross-chain solution in itself. You can also choose Axelar as a DVN provider, and that's a whole middle chain in itself. So at a high level, a message can only be executed on the destination chain once it has all the verifications required as per your configurations. I hope that makes it clear. Right, Hugh. Cool. So yeah, so those are the two questions. Anyone else, guys? Can I get some GMs at least in a chat? Sorry for yeah, not looking at this. Okay, any other questions? Nice. Cool. Um, so consensus is like votes, right? So to use the terminology of consensus, votes only when there are sufficient votes for a particular state, then that state is considered as canonical to the chain, right? It's accepted as true. Okay, is that clear, Hugh? Okay, before I move on to the next part. Okay, I'll just optimistically assume that is understandable to you, and and so in our model, the votes are the confirmation. So each DVN, when they verify, that counts as one confirmation, which counts as one vote. And your security stack configuration, you are able to say, I want three confirmations before the message is allowed to be executed, before the message is considered confirmed or fully verified, right? So it's like three votes. And who gets to decide again whether it's three and which ones? It's again you. So this is another differentiator of LayerZero, which is security is modular and configurable. You're allowed to configure how many DVNs that you want, how many confirmations or votes that your message requires, and also which ones, which verifiers you want to use. And again, this is important because depending on your use case, you have different requirements. So maybe you're building a meme coin app that is low value and just for fun, right? So you don't need things to be too high security, but you're more cost sensitive. So in this case, you might choose only one verifier. But then if your use case is high value, it involves transfers of assets, then you might want to have more than one verifier. And in fact, it is recommended for you to have more than one verifier. But the impact of that is that, of course, the cost is going to be slightly higher than just having one verifier. So yeah, bottom line the bottom line is that as application developers, you have the control over the balance between security and cost. And even when it comes to security, you have the control over which security methods your application will use to secure the cross-chain messaging. Yes, the power is in the developer's hands. Yeah, and again, this is a difference to alternatives that use a fixed validator set. That when you use their cross-chain messaging solution, that means you trust the same set of nodes or validators to attest to the messages between chains. This is where LayerZero differs because we don't force you to trust a fixed set of validators or nodes. Instead, we let you choose. And the neat thing is that, again, I told you that you can have Axelar as a DVN, as a verifier. And in fact, you can use CCI Chainlink CCIP as well as a DVN. And it's also possible for you to use Wormhole as a DVN. You need to have a DVN wrapper around it, but then it's also possible. Cool.
Okay, so what is the benefit of validator? They receive fee or something like that.
What's the benefit of what, V?
Validator, I mean the DVN, I mean, yeah. the
Sorry.
DVN. Can you move to the side of DVN? Yeah, yeah. What is the benefit of to become a verifier?
Yeah. I mean, yeah. So this relates to Hugh's question, right? So
Yeah.
verifiers earn fees from messages. So here, let's go to the send and verification. So when an application would like to trigger a cross-chain message, the message fees have to be paid for, and fees are broken down into several parts. So one, of course, to trigger a transaction on the source chain, there's just the fee for that transaction itself. But then, if you want to use the executor run by LayerZero, which means that on the destination chain, there's no longer a need to have a separate action to supply destination gas, then you can uh, get a quote of how much it will cost uh, in the source chain gas to pay for the amount of gas that you specify yourself. So we have a price feed on all chains that we support to help you figure out for this number of gas in the destination chain how much you need to pay in the source chain gas. And then aside from destination gas amount, you have the executor fee and also the DVN fee. So all of this is encapsulated into a simple quote call, and quote is referring to quote fees. When you call this method, you would get a single fee amount that is a combination of all these fees. So the that amount is included in the send message transaction, and DVNs will get paid uh, base as their payment is part of this amount that is sent. The fee is not using the LayerZero token right now. It is possible for the LayerZero token to be used for paying for fees, but that is not activated right now. So it's just paid in the source chain gas token. Yes. So when it comes to signing only one transaction to trigger multiple actions on different chains, this goes to the composability feature of LayerZero. Um, so pass by. I think let's just use this. Yeah, this slide. So yeah, so this again, it could be any cross-chain message, or it can be a token transfer. For example, for a token transfer, we have this feature built in to be into our contract standard, where you can specify an additional action to be taken after the token has arrived in the destination chain. So, of course, like one such use case is for the token to be swapped into a different token, or even maybe for it to be staked, right? So you bridge to another chain and you want that token to be immediately staked. All of this could be done through one single transaction on the source chain. So I'm not the right person to ask about utility for zero token holders right now. I can only speak about the fact that the zero token is not yet used for fees. Yes. So actually, here what ping pong table. We have uh, we have an approach or model called ABA. It's like ping pong basically, where you can trigger a message on chain A to go to chain B, and then in your omni-chain application on chain B, uh, have it send a message back. So uh, technically, it is possible because you can keep calling the send function to send to the other chain.
Yeah, okay. Mm, okay, I think this time, yeah, no more questions. So, if anyone had any question, feel free to reach out to us on Super Team Telegram group. And
Yeah.
yeah,
Or
okay.
yeah, like you guys can also reach out to me on Twitter if you want. Okay, question. Can we bridge assets from chain A, which doesn't exist in chain B yet? So technically this is possible. But that means that you have an unofficial version of that asset on chain B, right? And if that asset issuer creates their own version, which is the official version, then you have the unofficial version. But using our contract standards, it is possible. We have something called the OFT adapter standard, which allows you to have an asset on the original chain that it exists in, and then deploy uh, an OFT instance on another chain, link the two together such that the OFT adapter can send cross chain in a cross chain way to the other chain. So then, and then when it sends back from the other chain to the original chain, it can also be sent back. So it's possible, but again, on chain B, that means you have the unofficial version of that asset. Cool. Yeah, if you want to end the stream, then we can do that.
Yeah, okay. So, I think, okay. Thank you, Nas, for joining us today. And it was a very interesting workshop. We hope to see you again in the future sharing session with Super Team Vietnam. And for the audience, thank you, everyone. Good night. See you next week. Bye
Awesome.
bye, everyone.
Thank you, everyone. Thanks, Super Team Vietnam, for having me.